My name is ABDALLA MOHSEN, and I'm gonna represent the introduction and the literature review. Well, combinational logic is a sort of digital logic and that is implemented using Boolean circuits and has an output that is purely a function of a current input. The truth values, true and false, are generally labeled 1 and 0 respectively in Boolean algebra. It is a tool for analyzing and simplifying digital circuits or gates. We can then utilize this to figure out which inputs will result in a true outcome. However, we can create more complex circuits by combining a sequence of logic gates. Literature review: combinational circuits in which the state of inputs determines the state of outputs with ambiguity, and sequential circuits. Voltage logic gates, which are a part of a set of elementary combinational circuits, are commonly employed to physically realize combinational digital circuits. Sophisticated electronic circuits, reducing power consumption and reducing the area occupied by the circuit becomes a major issue.
Hi, my name is MUSAB and I will present to you the discussion. From the results, a 4-to-2 priority encoder has 4 inputs: speeds, hearts, diamonds, and clubs, and 2 outputs, Y and Z. Here the input S has the highest priority, whereas the input C has the lowest priority. And complete the truth table according to the cards. You can use the don't care cell as 0 or 1, and we can also ignore that cell if necessary. Next, minimum expression for the problem can be proceed by using K-map. For this problem, K-map for 4 variables is selected sum of product, is identified as given in the problem. Then after that, make rectangular groups containing total terms in power of 2, like 2, 4, and 8, and so on, except 1, and try to cover as many elements as you can in one group. As a result, a minimum expression obtained from K-map, which is y equal to c bar for y, and z equal s bar h bar plus dc for z. The conclusion: we used multiple methods to solve the combinational circuit. Step 1, conceptualized or get the problem overview, and step 2 was to obtain the truth table. Then step 3 was simplified Boolean expression that we used K-map to solve, and the last step to draw the logic circuit that represented the simplified Boolean expression.
My name is Joy Sijilin. Now I will present about the results. The description of the problem of this assignment is: a combinational circuit has 4 binary inputs, which is S represented spades, H represented hearts, D represented diamonds, and C represented clubs, and 2 binary outputs, which is Y and Z. Each input represents 4 sets of 13 cups in a pile of 52 pocket cups. Each input can only be 1 or 0, which means the input represents a 4-bit encoding SHDC base 2. Y will represent the inputs are even numbers, while Z will be inputs diamonds and clubs are greater than inputs spades and hearts. This is the block diagram. Here is the 4 inputs, which is SHDC. Then the output will be Y and Z. This is a truth table. So the next one is minimum expression for the problem using K-map. We got Y equals to C bar. Z, we got S bar, H bar plus DC. We got the logic circuit from the minimum expression.
Assalamualaikum warahmatullahi wabarakatuh. My name is NAJWA binti NORDIN, and next I will present to everyone about the demonstration on the quarters prime. And this is our schematic diagram. I've put all the logic circuits used in our logic circuit, which have NOT gates, AND gates, OR gates, and there are 4 inputs and 2 outputs. So we just need to connect all the logic gates together so that it can perform when I run in the simulation. After connecting all the logic gates, we run the simulation, and here's the result of our simulation, and there are no errors. And we proceed with the waveform, and here's the waveform. So that's all from us. Thank you.